Hello, welcome to Characteristics of Quadratic Functions. So you know how they change now, you know how they shift, and you know how to find a couple of things about them. One of the things that we need to make sure we can always find is the vertex and the axis of symmetry. And there are a couple of ways that we can do this based on how the equation actually looks. So if it looks like it did for the last video, it's in vertex form. And you can find the axis of symmetry, which is a line that divides the parabola into mirror images and passes through the vertex. So if you look at this little picture on the right, the red line is the axis of symmetry, because if you look at the left side and the right side, they're exactly the same. You could fold your paper in half and you would get the exact same thing on both sides, and they would match. So that's why we need to find the axis of symmetry, and the axis of symmetry is very closely related to the vertex. Because the vertex of f of x equals a times x minus h squared plus k is hk, the axis of symmetry is the vertical line x equals h. So the axis of symmetry is always going to be the h value. It's always going to be the h value. And remember, when you're finding the vertex, you always do the opposite or the inverse of what's there, because you have x minus h. And the x value is the h without the negative. Okay, so example 1 says to graph this function and label the vertex and axis of symmetry. Now there are a number of ways that you can graph something. We're used to graphing it in the calculator, and that's fine for now. Okay, but if you're going to plot points, then you want to pick good points. And whenever we graph, we need at least 3. Okay, we want to see 3 good points. Typically, when we're talking about good points in the calculator, we're talking about whole number points, or at least a point that you can plot, okay, and then base the rest of your graph on that. So to find good points, we know that the vertex is hk. So the vertex for this is going to be the h and the k, but the h is the opposite sign, so instead of +4, it's -4. And the k stays the same, so that's a -2. So let's go ahead and plot that. Okay, on our picture, plot -4, -2. Well, that's a point right there. That is our vertex. And it says to plot it and label it. So we did that. Well, the axis of symmetry, as you just learned, is the vertical line x equals h. Well, h is the x coordinate of your vertex. So the axis of symmetry is going to be the line -4, x equals -4, and it's always an x equals line. You cannot just put the number. It has to be x equals -4. If you just give me the number -4, you're going to be wrong, because that tells me absolutely nothing. Okay, that is not a line. So if we're going to label it, we can label it with a dotted line, and this is our axis of symmetry. X equals -4. Now it does say to graph, and if you're going to do the plotting, making a table, you want to pick points that are near -4. So to the left of -4 and to the right of -4. The number to the left of -4 is -5. Then you have -4, and then you have -2. Now when you're plotting it, remember, you're taking your x value and you're plugging it in to the actual function. So we have 0.5 times -5 plus 4 squared minus 2. You put that into a calculator and you get -1.5. We already know that -4 has a y value of -2 because that was our vertex. And then you do the same thing with the negative, not through 2. I want to put -3 there. Okay, so -3, 0.5 times -3 plus 4 squared minus 2. Again, you can put that into a calculator, any calculator. You can use the calculator on your computer, which you're probably watching this on, or on your phone. Your phone has a calculator. So we plot those points. We have -5, -1.5, which is about there, and -3, -1.5, which is about there. So that's what our picture is going to look like. And that is the parabola. Okay, we're always dealing with parabolas. So that is how you graph a basic parabola, knowing the vertex. We have to find the vertex. That's always our goal most of the time. So with parabolas, you know, it's an arc, and it can arc up and it can arc down. So we need to know that those are the maximum and minimum values. You will only have a minimum if your a is greater than 0. So let's look right here. Ax squared plus bx plus c. This is standard form. Okay, this does not give us the vertex very kindly. So what you really have to do with this is graph it, or we will give you an equation to find the vertex. But until we get that equation and discover it in class, we know that if a, this first number, the number in front of x squared, if a is less than 0, that's the right side. That's where a is less than 0. So that's when your parabola is facing down. It's opening down. If a is greater than 0, it's opening up. Think of it as if it's a positive number, it's a happy parabola. Positive and happy. That means it's making a little smiley face and it's facing up. All right, so the minimum value is always the y value of the vertex. If you can find the vertex, you can find the minimum. And that is just a number. Then you need to be able to find the domain, okay, and that's where you have your spirit fingers or your jazz hands or whatever you're going to call them, and then the left is always infinity, the right is always infinity, so it's all real numbers every single time. There's not going to be a time as far as quadratics where your domain is anything but all real numbers. And your range, well, that's very easy. You have a formula right here. Y is greater than the y value of the vertex if it's a minimum, and y is less than the value of the vertex, or equal to, if it's a maximum. Okay, so let's use this. Now, if you're graphing something and you are at home and you do not have a graphing calculator, I want to remind you that there is a website available to you. It is called Desmos.com. C-O-M. My stylus is not writing. So make sure you go there if you don't have a graphing calculator at home. There's no reason for you not to be able to graph at home. So, example 2. Find the minimum or maximum value of f of x equals 2x squared plus 8x minus 6. Describe the domain and range of the function and where the function is increasing and decreasing. So, maximum and minimum. We're going to find this, for now, just by graphing. And we're going to go to Desmos.com to do it. I have already done it. And we have a small issue right here. The problem is that our graph does not have the scale we want it to be. And if that ever happens, change the scale. That is not a problem at all. So let's change this to a -5. And I'm going to go in increments of 5. And if you look on Desmos.com, it gives you a very, very nice, pretty picture. My picture is not going to be very, very nice and very pretty because I am not an artist. And this is not the best scale, but we're going to work with what we have. Okay, if you look at Desmos.com and if you graph this, you will see, and I suggest you do graph this in Desmos or somewhere else so you can see that vertex. The vertex is -2, -14, because that's the lowest point on our graph. So that's about here. And that is -2, -14. Then they graph higher. They have the point 0, -6, and -4, -6. So that's what we mean when we say plot good points. We mean go and find good points. Don't just sketch a graph. Okay? Don't just sketch the graph. So the minimum here is the -14. That is our minimum, because that is the lowest y value. Now, the reason we have a minimum is because it goes up forever and ever and ever. If it were going down, we would have a maximum. But here we have a minimum. Now, Now we can find the domain, range, increasing and decreasing increments. And the domain, as we said, if we look over here, last page, says domain is all real numbers. And we have this situation, the a is greater than 0, so that means it's still all real numbers. So write all real numbers. Okay, and mathematicians can be lazy. We came up with the symbol like that to represent that. We also have interval notation where we have negative infinity to infinity. That would be the same thing as all real numbers. Now the range. Let's look back at what the range is for a is greater than 0. Y is greater than or equal to the y value of the vertex. So y is greater than or equal to the y value of the vertex. Well, the y value of the vertex here is negative 14. So we have negative 14. Another way to write that is 14 to infinity, negative 14 to infinity. And it was or equal to, so we closed that bracket. Now, where is it increasing? Well, let's look over again here. It says that it's increasing on the right side because that's where it's going up, and it's decreasing on the left side because that's where it's going down. So let's mark that. This is where it's increasing, and this is where it's decreasing. Well, that has to do with our x values because it's going left to right. So it is increasing when x is greater than our vertex. Okay, that negative 2. So x is greater than negative 2 or negative 2 to infinity. And it's decreasing where x is less than negative 2. So negative infinity to negative 2. And that's it. Okay, so if you don't have a vertex, we can always graph using Desmos.com or a graphing calculator as you use the Inspire in class. Now, what if it looks like this? Well, graphing quadratics using x-intercepts can be very easy. It can be very easy because it's something that it gives us 2 good points automatically. It gives us the x-intercepts. So this is x, this is intercept form. Okay, and P and Q are the x-intercepts. But just like with vertex form, if it's inside, you're always going to do the inverse of the sign that's given. Okay, if it's inside, you do the inverse. Inside, inverse. Inside, inverse. So let's find the zeros, and let's use this information as we go through example 3. So we have to do the inverse of negative 4. So we have a positive 4. Okay, and this is an x-intercept. So we're going to go to 4 on our x-axis, which is right here. Then we have the positive 2, but we have to do the inverse. So instead of being at positive 2 on the x-axis, we're going to be at negative 2. So we know something about our graph. Now, before, and the same rule applies, we have to look at our A to see which direction we're going in. That A is a negative. So that means that we are going down. Negative means that it's opening down. It has to be because it's negative. So that's good, Danny, to know. But we need to know the vertex because we need to know the highest point of this graph. Well, we have an equation for the axis of symmetry. The axis of symmetry is halfway between the P and the Q. So x is P plus Q divided by 2 for your vertex. So x is P plus Q divided by 2. Here our P is negative 2, our Q is 4, and we divide by 2. That's a 2. Negative 2 plus 4 is 2 over 2, and that's just 1. So we can label, because it tells us to, right? We can label our axis of symmetry. That's going to be at 1. So let's put a line here. That's the axis of symmetry. Right. X equals 1. Well, then we still need to find the actual vertex. Okay, so in order to find that vertex, we have to plug in 1 into our equation. So we're finding f of 1. Instead of f of x, x is 1. So plug in a 1. And we have negative 1/3 times 1 minus 4 times 1 plus 2. Well, we have negative 1/3. You can put this in a calculator. That's negative 3, and that's positive 3. And that'll give us the number 3. So at 1, at the x is 1, on our axis of symmetry, the y value is going to be 3. So we're going to come up to 3, and we're going to put a point here. And then we're going to draw our brow. Whoosh. We know it's going down because the a was negative. Okay, the vertex is 1, 3. And that's our vertex. So we've been able to find everything we need. We found our x-intercepts, we found our vertex, and we found our axis of symmetry. So we were able to graph and find those things. And that's always our goal, is just to find whatever the instructions tell you to find. Okay, so that we know something about our graph and we can actually graph it. Okay, so we've learned all of the information. Now we need to be able to apply it, but really we're just finding the vertex and the x-intercepts. So don't let word problems scare you. Here we go. The parabola shows the path of your first golf shot, where x is the horizontal distance, so this is the horizontal distance, and y is the height of the shot. So it looks exactly like the picture tells us it looks. The path of your second shot can be modeled by the function f of x equals negative 0.03x times x minus 40. Does your first or second shot travel farther before hitting the ground? Okay, well, the distance, it said, is the horizontal. So what we need to do is find out in our second shot, because this is the first shot. This is shot 1. We need to find out in shot 2 what that looks like. So let's draw our own little axis. We know we're starting at 0, 0 because that's the ground. Okay, and this right here is in x-intercept form. So it gives us the intercept. And remember, whenever you're finding that x-intercept, you're doing the opposite, the inverse of the sign that's given. So our other shot, it ends over here at 40, 0. Okay, that means that the first shot is 100, and the second shot is 40. So which one's farther? The first one. Well, so that means that the answer is the first shot travels farther. Apologize for my handwriting, but we have to make sure that whenever we answer word problems, we are answering them in complete sentences, because being able to communicate in complete sentences is a very important skill. So, which one travels higher? Well, we know the height, the highest point, the maximum, we know that the maximum is the y value of our vertex, which means that we need to find the vertex. And we're going to do that the same way we did in the last problem that we did. So first we're going to find our axis of symmetry to find the highest point of our vertex. Well, the axis of symmetry, remember, is that equation back here. Oops, too far. The purple circled one. Now I'm going to circle it in green. P plus Q divided by 2. So your x-intercepts divided by 2. Well, our x-intercepts are 0 and 40. So 40 divided by 0 plus 40 is 40. And 40 divided by 2 is 20. But that's the x. The height, according to this, is y. So we need to find the y value. Oh no, pretend I didn't do that. So the y value is where you take your x and you plug it in. So we're finding f of 20. So negative 0.03 times 20, because that was an x, times 20 minus 40. Well, that equals whatever your calculator gives you, which is 12. So 12 is the height. So if we were to mark this on the graph, we'd have the parabola arcing down, and this point is 2012. And we're comparing the y values. So we have the 25 and the 12. So which one is higher? Well, 25 is much higher than 12. So the answer is that the first shot traveled higher. So we have taken what we learned and we have applied it to a real-world situation, and golf is a good example of a parabola in real life because that's how the shot moves. It goes in an arc. So take this, make sure you have everything written down. Watch it again if you didn't understand something, because I'm going to expect you to start applying it the minute we get into class next time. Have a nice day.